Okay, so today we're going to be doing the solutions for our second coursework exam. So these are some of the instructions that were on the front page of the exam. Please pay attention to number 3, which says mysterious or unsupported answers will not receive full credit. So if you write your solutions all over the place and I can't follow them, you won't be getting any marks for those. So we're going to do the multiple choice section first. So we have to shade one of these here. So it says question 1 part A. If the coordinates of the points A and B are this and this, then the gradient M is what? So we have to use our formula here. So these are our 2 points. So if I can go ahead and take x1, so M is equal to x2 minus 1 over 7 minus 4. This will give me 4 minus 1 is 3, and 7 minus 4 is also 3, and 3 divided by 3 is 1. So therefore my answer for this is A. Is the first choice, right? It's 1. Next, we're moving on to part B. It says that find the equation of the line passing through the points 2, 3, and 3, 5. So once again, before I even use my point formula, I need to find my gradient, M again. So I do the same thing I did in the first part A. So this time it's 5 minus 3. So it's 3 all over 3 minus, which will give me 2 upon 3 minus 2 is 1. So this is 2. So now I need to put it in the form y is equal to mx plus c. So let me choose y. So we have, I don't really have much space here. So I'll write here y minus, let's choose this point here. 3 is equal to 2 into x minus 2. So y minus 3 is equal to 2x minus 4. So make y the subject of the formula. It's 2x minus 4 plus 3. So y is equal to 2x minus 1. So my answer here is part 3. Y is equal to 2x minus 1 is my answer. So moving on to part C now, the midpoint of the line segment joining the points 1, 4 and 3, 4. So now I need to use my midpoint formula. So if you remember from my notes, my midpoint formula, I'm just going to plug in my coordinates immediately. So I'm going to take 3, take x1. I'm going to add it now to my x2, 1, 2, comma, and take my y2, add it to my y1, all over 2. And this should give me 3 plus 1 is 4, 4 upon 2, so 2. So it's either 2 or 3. And 4 plus 4 is 8. And 8 divided by 2 is 4. So therefore my answer is 2, 4. So I'm going to pick here. Next, we're going to move on to the quadratic polynomial x squared minus 3x minus 4 is equivalent to which of these here. Now, I can go ahead and take each one and multiply them quickly since it's multiple choice and just find which one gives me this answer here, right? And if I do that, I'm going to see that my answer here is this choice here. Okay, so just multiply each one and see which one gives you this. Part E. By the remainder theorem, the remainder when f of x is divided by x minus 5 is what? So here we are asked by the remainder theorem. So, but if we don't know what f of x is, but it doesn't matter because they ask us for the remainder. And the remainder, when we have our factor here, is when I set x minus 5 is equal to 0. So what number here will give me x minus 5 is equal to 0? That's when x is equal to 5. So that's my answer is E. Okay. Moving on to part F now. We have to solve this inequality here. Okay, so we need to do some work on this modular sign, remove it, and find an inequality here. So if we go ahead and I'm going to skip a lot of steps here and let's go straight to x minus 7 is less than negative 12 or x minus 7 greater than 12. Now just add 7 on both sides here. So we'll get x is less than negative 5 or x greater than 19. And that is this answer here. It's not this one, it's not this one, it's not this one. It's this one. By just removing the modular sign. Okay. Next, we're going to move on to G. Solve the inequality here. So to solve this inequality, we need to make x the subject of the formula. So I have two denominators here which are not the same, so I can't multiply throughout by 3 or 2, right? So let me go ahead and maybe take this 2 upon 3 and bring it on this side, so I can say that 7x 7 upon 2x is greater than 3 minus 2 upon 3. That will give me 7 upon 3. So I can multiply by 2 here. Let's go ahead and do it. Multiply both sides by 2. I'll get 7x is greater than 14. Oops, 14 upon 3. Now divide both sides by 7. I'll get x is greater than 14 upon 3 multiplied by 1 upon 7, which is 2 upon 3. So my answer here is B. Okay, moving on to part H now. Oh, this is a bit of a tricky part, right? So I'm given f of x is equal to this and g of x is equal to this. So now I have to solve, sorry, now I need to find which of the following is true. Now I can go ahead and look at the easier ones first, like find f of 1 and what is g of 1, see if they are equal or not. Right? That's one way to do it. Another way that we can do this is that we can, okay, so this is an easy one to look at, but immediately if I put 1 inside here, I'm going to get 1 plus 1, which is 2, 2 upon 3. Now g of 1 is 3 plus 3 by 1, which is 3, minus 1, which is 2. So immediately I rule out that this is not an answer. Okay, this is not an answer here. What about this one here? This means I have to go and find the inverse. That's a lot of work, right? Let's look at this one here. So f inverse of x upon g of x is equal to the empty set, but we already solved here, and I have a number here for f of x and I have one for g of x, which means that they in fact are not empty. So I can rule out this immediately. What about this one here? F of x is equal to f inverse of x. That doesn't sound right to me. Can I find a function and then the function is also the inverse of the function? Maybe there's an example out there where this is true, but based on my two functions here, this is not true. So this is the only one that's true here. And if you want, you could go ahead and do them separately. Find f of g of x and g of f of x, and you'll see that they are in fact equal. So the answer for this is 4 over here. Okay. Moving on, the solution to the system of equations this and this are what? So in order to solve this part of now of this problem, it's easy, just like the simultaneous equations we had before. Sorry, the quadratic polynomial, where we could just do trial and error, multiply each one and see which one gives us this. So over here, just put in values for x equal to 3 and y equal to 4, or vice versa for each one, and you can find one. Or you can go ahead and solve these two equations simultaneously and get your answer. If we do that, we're going to see that this is the only option here that is true. Okay, and lastly, which of the following is true about the discriminant b squared minus 4ac is greater than 0? This is straight from our lecture notes. We get two different real number solutions. Different, right? Two solutions, both neither real nor imaginary. This is not true. Two different solutions, one real and one complex, but we have greater than 0. This is not true. And two repeated real number solutions, but they didn't tell us if the repeated solutions here are the same or not. It's very it's very open-ended, right? So this is not true. And this, if you remember, it is straight from our notes. And this is the MCQ part of this exam. Now we're going to move on to the structured questions. So it says find the intersection of the two lines using only, okay, they specified for us, only using the substitution method. And we have two equations here. Okay, so let's label my equations first. So this is 1 and this is 2. It's 2. Okay, so you can choose any one that you like. I'm going to go ahead and choose equation number 2. You can choose one if you like. So I'm saying take equation 2, and make x the subject of the formula. Okay, when I do that, I'm going to get now that x is equal to 2y plus 3. Okay, let's call this equation number 3. Remember, this question is 4 marks. So let's see how these marks stack up. So let's just say for this, we get 1 mark. Okay. Now, I'm going to substitute equation 3 back into equation 1. We do not substitute the equation that we make our variable, our unknown here, the subject of, back into the same equation. So if I would have used equation 1 and make x or y the subject of the formula, then I would have substituted that new equation into 2. Because I used equation number 2 to form this new equation, I have to substitute it into 1, right? So let's write that. Substitute equation 3 into 1. When I do that, let's see what I get. So I'm going to get 3y plus 2, 2y plus 3 is equal to 20. And just for writing this only, you'll get a mark. Okay. Now let's expand these brackets here and get what my y is. 3y plus, so take everything and multiply it over here now. I'm going to get 4y, and 3 by 2 is 6, is equal to 20. Then we have 3y plus 4y, that's 7y plus 6, oops, is equal to 20. So 7y is equal to 20. Take this 6 and bring it on the other side of the equation. You'll get negative 6. So 7y is equal to 20 minus 6. So that's 14. Now to get y, we divide over here both sides by 7. And we'll get 14 on 7. Y is equal to 2. So I have found what y is just for finding y, right? And all of this here coming down, I get 1 mark. Now I need to solve for x. So take my new y, and we're going to substitute this new y back into equation number 3. So you can say substitute y is equal to 2 into 3. When I do that, I'm going to get x is equal to 2 into y is now 2 plus 3. So x is equal to 4 plus 3. X is equal to 7. Just for finding what x is, I'm also going to get 1 mark here. That's how I get my 4 marks for this question here. Okay, so to recap, I chose equation 2. I made x the subject of the formula. You could have made y the subject of the formula, or take equation 1. Anyone is fine. And then after I did that, I substituted that back into my first equation, not the equation that I made the subject of the formula. I broke it down, I solved for y, and then I substituted my new y back into my equation number 3 to solve for x. So x is equal to 7 here, and y is equal to 2. And if you really want to check, you can substitute these values back inside here to ensure that this is correct. Now we're going to move on to part B. It says if f of x is equal to 2x minus 1, then find f inverse of x. Okay, so let's write some statements. The given f of x is equal to 2x minus 1, we have to find f inverse of x. So in order to do that, let's consider y is equal to f of x. And of course, the theory of this was already covered in our lecture notes. So if y is equal to f of x, and this is my f of x, then write y is equal to 2x minus 1, because that is what my f of x is. So just for writing this, based on this current mark scheme, I will get, let's say, a half mark, just for writing this. Okay. Now, I need to interchange my x and y. So let me write that. So I could say now interchanging x and y gives us, what will that give us? So wherever I see x here in this equation, I put y, and wherever I see y, I put x. So I'm going to say that x is equal to 2y minus 1 by taking this equation here, right? Just for writing that, I'll also give myself a nice half mark. So it tells me that I know exactly what I'm doing. Now, I need to solve, meaning that I need to make y the subject of the formula. So 2y is equal to, take this and bring it on the other side, I'll get x plus 1. So y now is equal to x plus 1 all over 2 by dividing both sides here by 2. Therefore, for f inverse of x is equal to x plus 1 all over 2. And again, just for writing that, I'm going to give myself an entire mark because that is exactly what they asked us to solve. Find f inverse. So what did I do? I said consider y is equal to f of x. I took y and I had my f of x already here. Then I interchanged x and y to give me this over here by replacing wherever I see x, I put y, and wherever I see y, I put x. Then I have my 2y, I interchanged to make 2y the subject of the formula. Then I made y the subject of the formula by dividing throughout by 2. And then I restated my answer here in a nice way so I'll know exactly what my f of x is. And this here is question number 2. Now that we have finished question number 2, let's move on to the last question, number 3. Okay, so this is a factorization type kind of question. We're going to use polynomial long division and the factor theorem, and maybe the remainder theorem as well. So we're given here a function f of x. Part A says use the factor theorem to show that x minus 3 is a factor of f of x. Now, if it is true, and it is true because they are asking us to use the factor theorem to show that we already have one of the factors of this f of x, and it is x minus 3, right? So they are telling us that it is a factor of this, and there are others that we may have to find. So in order to do that, let's talk about the first part. So it says use the factor theorem to show that this is a factor of this. If it is a factor of this, then that means if I set x minus 3 equal to 0, and then I'll solve for x, which means that x here is equal to 3. Okay, which means that if this here leaves a remainder, x is equal to 3, then it means that this here, if I substitute it into f of x, I should get 0. So let's try that. So for part A, let's write A, f of 3 is equal to 2 by x cubed, which is 3 cubed, minus 9 by x squared, which is 3 squared, plus 7 by x, which is 3 plus 6. If you plug all of this into your calculator, you will see that your answer is in fact 0. Try it yourself and you will see. So this is 2 marks. So just for writing f of 3, I will give myself a nice half mark. For all of this substitution here that is correctly done, I'll also give myself a half mark. And for actually getting 0 here, I'll give myself a half mark. But wait, I'm not done. Right? I need to say, it says use the factor theorem to show that is a factor. I got 0. So now I'm going to say and prove to my examiner that I know exactly what I'm doing. So I'm going to say, hence, x minus 3 is indeed a factor. And for doing that, I'm also going to give myself a nice half mark. And that's how I get 2 marks here. By saying f of 3, that tells me and that tells the examiner that I know exactly what I'm doing here. I know that this over here is my remainder here is, by solving this, I get 3, and then I substitute it inside here. So this is part A. Let's move on to part B now. So part B tells us to use polynomial long division. Part B, it says to use the polynomial long division. So verify the result. So remember, they already told us that x minus 3 is a factor. So let's use that. Let's use x minus 3 here. So x minus 3, my long division sign, 2x cubed minus 9x squared plus 7x plus 6. So now the tedious part, okay? So I need to divide this 2x cubed here by this x. That'll give me 2x squared, or as some people like to say, what can I multiply x by to get 2x cubed? That's another way of saying it. It's fine as well. It's easier to divide here by x. So I get 2x squared multiplied by x. That'll give me 2x cubed. And then 2x squared by 3. And of course, there's a negative sign in front here. So I'm going to say negative 6x squared. Draw a line and put my minus sign here and subtract these two. So this minus this, I'm going to get 0. I'm going to put my minus sign and I'm going to say 9x squared. Actually, let's not put this right yet. Let's minus negative 9x squared minus negative 6x squared is negative 9x squared plus 6x squared, and that is negative 3x squared. And then take the 7x and bring it down here. Of course, it's plus 7x. Now, take negative 3x squared here and divide it by this x here. When I do that, I'm going to get, so put a minus sign because it's a minus sign here, right? When I divide this by this, I'll put a minus sign here. So when I divide this by this, one of these x's here is going to cancel with one of these x's here. So I'm just going to remain with 3x. Now take my negative 3x and multiply it by this x to verify. So negative 3x by x, that's negative 3x squared. Okay, that's fine. And negative 3x multiplied by negative 3, that will give me positive, because a negative sign by a negative sign, give me 9x. Draw my line, put my minus sign. Negative 3x squared minus negative 3x squared is negative 3x squared plus 3x squared. That will give me 0. And 7x minus 9x is negative 2x. Take this 6 and bring it down here. Of course, there's a plus sign here, so I put plus 6. The procedure is the same. Take x and divide it by this negative 2x. So the x's will cancel, and I'll remain with minus 2 and negative 2. So negative 2 multiplied by x here is negative 2x. Negative 2 multiplied by negative 3 is positive 6. Draw my line, put my minus sign here. Negative 2x plus, because these two negative signs will come together, 2x, that'll give me 0. And positive 6 minus 6 is equal to 0. So my remainder here is in fact 0, which I should get because they said that to verify the result. So when I divide here by long division, I should get 0, and I did get 0, which means that this x minus 3 is indeed a factor, and my remainder is 0. So how do I stack up my 4 major marks here now? So I can maybe... So therefore, if I get, let's see, I can give myself, so all of these here, For each one of the correct factors, I'll give myself a half mark for each. If my remainder is in fact 0, over here, I'll give myself a half mark. I forgot to write one important step, which is that, say that remainder, remainder equals 0. I write that. I'll also give myself a half mark. So that's 1, 2 and a half. If I do correct here, long division, I'll also give myself a half mark for that, from here to here, and from here to here, half, and from here. So 1, 2, 3, 4. So that's 4 marks. So these are how my marks stack up in this part of the question. So now that we have done that, A and B, let's move on to part C and D, which it says to factorize f of x fully. Now, I have f of x here. I have one of the factors here, which they already gave me. And lucky for us, we performed polynomial long division here, which means that this 2x squared minus 3x minus 2 multiplied by x minus 3 will give me back this, which tells me that 2x squared minus 3x minus 2 is also a factor. So how do I write that? So let's see. So for part C, I'm going to say x minus 3. That's the first factor they told me about. And then I have the one that I found by polynomial long division. But the key word here is fully, which means that this is in the form of a quadratic, which means I need to also factorize this. And this is a very simple factorization that sums up to 2x plus 1 by x minus 2. Of course, if this gives you some trouble, you can do it on the side working and then find the factors that add up to give this but multiply to give this, and so on. So once we get our answer, we get an entire mark for writing this according to the curriculum, and an entire mark for writing this if it is indeed 2 marks. Of course, these things are subjective based on the amount of points that are awarded per question. So perhaps there was another polynomial long division that needed to be done in which the remainder was not 0, then the mark scheme would be different. Okay, so this is part C. Now we're going to move on to part D, which says, hence, solve f of x is equal to 0. So this is part D. So what does that mean? Solve f of x is equal to 0. Well, again, lucky for us, these questions are set up in such a way that each part flows seamlessly, in that when you do one part, the other part that follows, you need to make use of the previous part of the question. So because we already factorized this fully, then we just need to take what we have factorized, set it equal to 0, and solve it. Which means that take this here, which we have factorized, and set it equal to 0, and solve it. So let me do that. Set equals 0, that's what they told me to do. F of x equal to 0. This is f of x in its factorized form. It's equal to 0. Now what do we do? It's have to solve it. So let's do each one separately. So for the first one, my first factor, which we already know, which we already found, which they gave us, we got 3. For the second one, we have 2x plus 1. Set that equal to 0 as well. So x is equal to negative a half. This one here, x minus 2, set that equal to 0, which means that x is equal to 2. So let's check and see the mark scheme for this one. It's 1 mark. So we get one entire, actually we get a half mark here for just setting f of x equal to 0, because that is what they told us to do here. So we do that and we get a half mark. And then for solving each of these, which isn't anything too tedious or difficult, we can do it by simple observation. We get an entire half mark just for doing this. Okay, and these are how the mark scheme will look. Okay, so this was the solution for coursework exam number 2, following which we did midpoints, factorizations, and some, but not a lot, of functions and inequalities as well.